Lecture 11 about data source design patterns. We're going to focus upon those design patterns that apply to that interaction between object-oriented systems and relational databases. And we're going to look at three patterns in particular: table data gateway, row data gateway, and active record. And the problem can be stated in this way, that what we have is an object-oriented program that needs to interact with a relational database, and the two paradigms just don't naturally mix. What we have thus far is SQL embedded into the servlets in our internet applications. And this can make maintenance a bit awkward, never mind the fact that we've got to try and work out some way of getting the relational information into objects on an object-oriented structure. So there are a few other problems that are mentioned there. Even if we were to do like we have seen in the previous lecture, and put all the SQL statements into one interface, that doesn't really remove the problem of complete lack of object-oriented structure. And so we're going to look at three patterns that might address this problem. The table data gateway is essentially a wrapper class that allows us to provide some interface methods so that we can interact with the database. And it's called a table data gateway because the class will focus on one table in the database. That class will have an update method, an insert method, a delete method, and then a series of find methods that will allow us to query the database. This class will hold all the SQL that's necessary for accessing that single table, and what we'll typically find in an application is that there will be one of these gateway classes per table. So if you've got 5 tables in your database, you'll have 5 different table data gateway classes. All the other classes in your application will then make use of the methods in this class to interact with the database. So they no longer are interacting directly with the database. They do it via the gateway classes. And so what that is doing then is separating the concerns, separating database interaction from the rest of the application, so that the application can focus on the object-oriented way of dealing with data. There's now an interface, a buffer between the object-oriented application and the relational database. What we've got to do is then think, well, if these find methods are going to query the database, they're going to extract data. How is that data then going to be presented to the rest of the application? For example, we could use a record set pattern, which is a standard design pattern, which essentially represents query results as rows of data. In other words, the result set object that we've been using up till now is essentially an implementation of the record set pattern. Alternatively, we could use what's known as data transfer objects, DTOs, which is another kind of pattern which wraps up data that is logically grouped, for example, row data, in one particular object. So if you have a result set from your query that gives you 4 rows, then you would generate 4 instances of the data transfer object. And again, this is very similar to what we've been doing thus far in the internet applications. We've been querying the database, getting the result set object, and then for each of the rows we've built what we've been calling them beans, but they're essentially data transfer objects that have been used then to pass the data from the model over to the view. And it's the bean that has been transferring that data. What I'm going to do is show you an application, an example, where the table data gateway has been used. And what I've done here is split up using packages the various parts of the system. We've got the model components, those are servlets that are buried away in this package. We've got the control, which is in the commands in here. The data transfer objects are in the beans, and the bit we're going to look at first is the table gateway. Let's take a look at the department. If we were going to query a standard introductory Oracle database, where you've got the dept table and the emp table, and you wanted to extract the information from these tables, then you would use a table data gateway. So if we look at the one for the department table, what I've got here is a concept you've now seen before, where we have as static, that is class level constants, they're finals, of type string, which embodies the SQL statements that are going to be used by this class in the interaction with the database. You can see here that we've got to select everything from the depth table and order it by dname. So no parameterization there. Here we've got some parameterization because we want to select the department by ID. So we're going to identify which department number we want to extract from the database, and so on. We've also got a couple of variables for the database username and password, which come from whoever creates the object. They have to provide as parameters the username and password for this database. Then we have the find methods. Here we have find all. Well, find all is going to make use of the all departments SQL statement, select star from depth order by dname. What it will do is connect to the database, as we've seen before. We're going to create a statement and then execute a query because the string in all departments is simply select star from depth order by dname. There's no parameterization going on, so we don't use a prepared statement. There's no need to. So we create a statement, execute a query using that string, and then process it as usual. While rs.next, we're going to do some processing. And that processing is, in this example, call a method called createDepartment, passing in the result set object. And then it will return an object of the department record type. Now, department record is a data transfer object, and I'll talk a bit more about that in a few moments. In the next find method, this is find by ID, which takes as a parameter the ID of the department. Now this is different because depth by ID is parameterized. Select star from depth where depth equals and then the question mark. That question mark is a placeholder for a parameter. In the find by ID method, when we have connected to the database, we're going to set up a prepared statement because we can parameterize prepared statements. And when we, from the connection, call prepare statement, we pass in that string. This is the string with the question mark in it, the placeholder for the parameter. And having created that prepared statement, we then can call from the statement the setInt method, saying that the first placeholder, well, there's only one here, but we still have to say which one it is. The first question mark is going to be replaced by the value held in the variable ID. And then we call execute query. And thereafter, we just process the result set as we would in any other situation. Again, what we're going to do is to call the createDepartment method, passing in the result set. And then we do similar things with find by name. In this method, the insert method, we have an array list of department records. Remember, this is a set of data transfer objects that just holds data that we now want inserted into the database. And what we would put here is some code that would have all the SQL necessary to take the data from the array list, construct some rows essentially, and insert them. The reason I've not put that code in there will become apparent when you read the tutorial worksheet. Likewise with update. Now this method that I've mentioned a couple of times, createDepartment, that takes the result set as its parameter, and it's going to create a new instance of department record. And if we take a quick look at what department record is, it is what we've been calling up till now, beans. So it's a data transfer object that has the necessary properties that will match the columns in the database table that are given default values when the object is constructed, and then by calling the set methods we can change those values, and by calling the get methods we can obtain those values. And therefore what we're going to do in createDepartment in this example is from the result set get the data from the current row and store it in the data transfer object by calling the appropriate set methods. And then that variable, D, which is the department record, will be returned at the end. And having been returned to, let's say, find by name or find by ID, it doesn't really matter which, but or even the find all. Having created the object, it's then stored in our reference here, and right down here at the end, it is returned. So this find by ID returns a single department record, in other words, a single row, whereas find all is going to return an array list of those data transfer objects. So if that's the table gateway, we now have to consider how it's used. So we've set it up. What we've got to do next is to think about where and when it's going to be used. Well, this is to do with database interaction. Therefore, that's part of the model in our MVC architecture. So in the servlets.model package, if we get all locations, then the first thing that this servlet does is to obtain from the session scope the attributes username and password. These are the database username and password. And then it creates a new instance of the department table gateway class, passing in username and password. That gives us then this variable dept table, which is our gateway. And then we can call findAll from that gateway object. And the findAll method, if you remember, returns an array list of department record objects, which can then be stored in a variable. And then we can process that variable in a for loop, for example, to set up whatever we want to do. Now, in this case, what we're doing is creating another data transfer object called location, which is then used as the beans for the view. There might be a little bit of overkill here, but I just really wanted to show, for reasons that might become apparent later on, the very clear separation between transferring data from the database to the model and for another data transfer object for transferring data from the model to the view component within the architecture. Now, of course, this is just causing our number of classes to grow rather rapidly. If I expand all of these, you can see that we've got rather a lot of classes now to do something that is actually fairly simple. But as I mentioned last time in the previous lecture, that isn't necessarily a problem, because it means that everything is very well structured, which makes it easy to find your way around the application, because we're using these patterns. Not only does it make it very structured, but each class has a very specific job to do, and therefore it only has to focus on one thing. So in many ways it makes the programming easier. It certainly makes the maintenance and debugging easier. So that's the table data gateway example.